Welcome to this short video, hopefully, on the survey project Part D and doing data analysis. Because there's some math involved here and some analytics, I wanted to talk you through this in addition to the worksheets and assignments that's in the assignment in Canvas. So the first thing that's going to happen is you're going to get an Excel spreadsheet with all the results of the survey. This is an abbreviated one. You'll see that the first columns, let me pull up my pointer, that might help. You'll see that the first columns are just a numerical listing, and then there's a timestamp, and then there's a unique identifier. This is so we can go back if we need to. And then we have our independent variable questions. What's your gender? How old are you? How would you classify your political beliefs? What's your spiritual affiliations, your relationship status, etc.? And you can see all the responses here. And then we go into the Likert questions, or the attitude questions, the proper way to prepare steak to maximize flavors to cook it rare. So your questions are going to be in here, but you're also going to see all the data from other groups' questions. And so what you're going to try to do is you're going to be looking at the categories and how they, your hypothesis categories, and specifically how they relate to the attitudes that you thought would happen, and do some analysis on that. And so hopefully, if you don't know Excel, being able to do some manipulation in Excel, sorting things, even building your tables, your calculation tables for Part D could be very helpful here, as opposed to just putting them in a Word document. So we have this spreadsheet with a lot of data in it. What do we do now? Well, we want to go back to our hypotheses and figure out which independent variables we need to look at, and then also which attitude statements we need to look at. So for my first hypothesis, I had males tend to support cooking steak rare more often than non-males. And so if I go and look at the spreadsheet, I'm looking at two different columns of data. I'm first looking at the gender, which is this first highlighted column, and then I'm looking at the belief statement. The proper way to prepare steak is to maximize flavors to cook it rare. So notice I've got the gender in my hypothesis and about cooking steak rare, which is the actual action. Okay. What I'm going to do now is I'm going to calculate, I'm just going to count the number of responses in each of the Likert scale. How many females answered strongly agree? How many females answered agree, neutral, disagree, strongly agree, and then do the same thing with the males. How many males strongly agreed, etc. And I can see their responses here. Remember, a 1 is strongly agree, a 2 is agree, 3 is neutral, etc. And I'm just going to build a little table with those actual numbers in there. So if I look at my numbers here, I can see that there are 9 females, and every single one of them strongly disagreed with this statement. So I had 0 1s there, 0 2s, 0 3s, 0 4s, and all 9 of the women answered 5. Okay. When I look at the males, I had 0 1s, so no one strongly agreed. I have 1 2, which is agree, so I plug that in there. 1, where am I at? I got lost. 1 3, so I plug that in there. I count the number of 4s, 1 2 3 4. I had 4 4s, or 4 disagree, and then I had 5, 1 2 3 4 5 5s. That's kind of weird. So totally, I had 20 people answer the survey, and this is a good check to check your totals. 9 and 11 equals 20, so everyone is accounted for. All right, and that's our first part, is just to pull the data out and look at the independent variable. In this case, it was gender, and then how people responded. So we've calculated, or we just tabulated how many females and how many males responded at each level of the Likert, specifically to their belief in the statement, the proper way to prepare steak to maximize flavor is to cook it rare. Now all I've done here is added another column, and although the model in your assignment doesn't have another column, I think it's easier if you do create an extra column for the percentages instead of writing them in parentheses or italics or whatever. It just is easier to read in my mind. Okay, so what we're going to be doing, and we're calculating percentages, we're going to be calculating the percentages of each independent variable dimension. So for example, we're going to calculate the percentages of females in each category, the percentages of males in each category, and then the percentages of responses totally across the board to the category. Now, how do we do that? This is where it gets a little confusing because we're doing different totals. Since we're looking for the percentages of females in this second column here, we're going to divide the number that actually responded by the total number of females, or 9. So we're going to just go down and do 0 divided by 9, 0 divided by 9, etc., and calculate the percentages. Okay? For the males, we're going to divide by the total number of males. So in this case, we're going to divide by 11. There were 11 men that answered the survey. So 0 divided by 11, 1 divided by 11, 4 divided by 11, 5, etc., to get the percentage. Okay? And then for the totals, we're going to divide by the total number of responses, or the total, which is 20. So 0 divided by 20, 1 divided by 20, etc. So if I do all those calculations, and I'll just show them here. So for example, 1 divided by 11 is 0.09, which remember is the equivalent of 9%. 5 divided by 11 is 0.46, or 46%, etc. 14 divided by 20 is 70%. 4 divided by 20 in this last column is 20%, 0.2 or 20%, okay? So you're actually doing percentages. So here we can see that 100% of females strongly disagreed. When we look at the males, we can see that 9% agreed, 9% had no opinion, 4% disagreed, and 46% strongly disagreed, okay? And then here we're looking at the overall total. So no one strongly agreed at all in our survey. 5% agreed, 5% were neutral, 20% disagreed, 70% strongly disagreed, etc. And so this is starting to give us some data, some insight into the survey and whether our thinking is correct. All right. So when I look at this, I can see that technically or mathematically, my hypothesis is correct that males tend to support cooking steak rare more often than non-males, okay? Because I have, if I look at these two categories, strongly agree and agree, I can combine them to get all the people that tend to support this. And we're going to look at another one and go through it again. But so males did support it. 9% of the males, one person supported it over the females who no one supported. So while it's technically correct, there are some flaws with this, and this is what you're going to be drawing out when you do your PowerPoint presentation talking about it. One, what's the problem with this? Well, first of all, our sample size is pretty small. We only had 20 people surveyed, so I'm not really sure about that. Second, the data is, while one person did agree, one male did agree and no females, this really is only one data point. It's really not a trend that I would feel confident say that supports my theory or that males tend to support cooking steak rare. So it's not enough data to really validate that. And so I'd have to go back, and probably what I would say is I need a larger sample pool. I might look for some other things that might cause, some bias here or something. Like perhaps I didn't realize, but when I go back and look at the survey, maybe everyone I interviewed was a Buddhist or Hindu or something that might have led them a different characteristic of themselves that led them to being a vegetarian. And so even though that may not have been your independent variable, my independent variable, again, remember, is gender. I can also look at the other independent variables that are in there, even if they weren't mine. and one of them is certainly spirituality or religion and age, etc. So don't be thinking that you just look at your own independent variables. I would suggest you look at all the variables and see if you see any trends there. Are more Christians eating red meat than Buddhists? Are they more supporting your belief statement than another group? Okay. So, but this is the basic way you're going to do it. Again, you're just going to simply look at the independent variable characteristics, and this was male and female. I could have done male and non-male based upon my original hypothesis, but I just used what was in the survey. I just put the actual numbers as they respond, 1, 2, 3, 4, 5. You remember, strongly agree is 1, agree is 2, etc. So it's in the chart. I just calculate the numbers, add them up, 9, and then for each column I'm going to divide by the total in that column. So I did the same thing with the males. One answered strongly agree, one answered agree, which was a number 2 in that column. One answered neutral, which was a number 3 in that column. 4 males answered disagree, which was a number 4 in that column, and 5 males strongly disagreed, which is indicated by a number 5 on the Likert scale. Then we came back and we calculated the percentages, just as I said. And now this is what we're going to use to kind of think through, how did our survey or experiment work? Did it support our hypothesis? Like I said, in here I would say, well, while technically and mathematically it does support our hypothesis, there's really not enough data to show that, because only one person agreed versus 0. And so I just don't have confidence that it's a strong support of the statement or hypothesis. And my recommendation would be to continue surveying people, a larger pool in this case. So most of you have more than one statement for each of your hypotheses. So we're going to need to analyze each of those statements. Here again, I'm analyzing the same thing, that males tend to support cooking steak rare more often than non-males. But I also have another statement, which is, to be a top chef, one should cook steak rare. And we do this because we want to, reframe questions or frame questions from different angles to see if the data is consistent across the board. And interestingly here, we kind of get a whole different animal, so to speak, about what people believe. So again, remember, the first thing I'm going to do is simply, sort by the independent variable, in my case, gender, so it's easier for me to count, and then do a secondary sort by their Likert scale, 1 for strongly agree, 4 disagree, etc. And then I'm just going to simply count the numbers. And here I can see I have 1, 2, 3, 4, 5, 6 women strongly agree, so I put that there by the number 1. I have 1 woman who agreed, I put that there. I have 2 women who marked number 3, which is neutral, so I put that there. And I don't have any, that's all my total of women, which is, of course, is still 9, because that was the total number of women in the survey. I then do the same thing and count the number of 1s for male, which was 4, or strongly agree. I count the number of 2s, which was also 4 for males, which agree, the number of 3s, and then I had no disagree or strongly disagree. So the first part is just kind of tabulating those numbers, and now I'm going to add some columns and go back and do my percentages again. So again, we are going to add a column after the number of females. We're going to add a column after each of the independent variables, number of females, number of males, and then of course a total column. We're going to go through and calculate the percentages again. For the percentages of females, we're going to divide by 9, or the total number of females. For males, we're going to divide by 11, or the total number of males. Whatever's the total in that column, that's what we're going to divide by for the percentage in the column. And then, of course, at the end, we're going to divide by the total, or the number of people that responded to the survey. And we get these numbers. So, for example, 6 divided by 9 is 66%. It's 0.666, which rounds to 67%. 1 divided by 9 is 0.11, or 11%. Here we get 4 divided by 11. The total number of males is 36%, 0.36 on our calculator, which of course is 36%, and 3. Now, when we add these up, this is a quick check, we should get 100%. But notice in the second column, we only get 99%. Did we do something wrong? No. As long as you're within a percentage, you're okay, because what's happening is it's a rounding error. So, for example, 4 divided by 11 is 0.363636, etc. And 3 divided by 11 is 0.27, 0.27, 0.27. And so when we're, rounding this to percents, it just is, it's an estimate and a close estimate. So as long as this is 99 to 101, you're pretty good. If you're outside of, a margin of error of 1%, then you've probably done some calculations wrong here. And then, of course, the total number of people that agreed was 6 plus 4, or 10. That was strongly agreed, excuse me. The number that agreed was 1 female and 4 males, or 5 total. 2 females and 3 males is 5 total, etc. And we do the same thing here. 10 divided by 20 is 50%. 5 divided by 20 is 25%. So we see a totally different situation here. To the first attitude statement, there was no agreement from any female, and now we have all agreement to this statement. So this kind of complicates things. So while they did not agree that you needed to cook steak to make it tasty, they did believe a top chef should cook their steak rare. So it's interesting how the data comes out, and we have to interpret that. And so what I'm going to do is now I'm going to show you how to kind of make these a little bit simpler, just agree and disagree, and then put them all together. So here what we're going to do is we're just going to simplify the chart, combining or summing together all the responses that were agreement and all the responses that were disagree. All we're going to do is simply add up the number of responses that were both strongly agree and get a total. We can even add up the percentages, then add up the total of disagree and strongly disagree to get a percentage here as well. And this just makes a simpler chart to kind of see where people are falling for or against an idea. And so this can be helpful, especially when you're doing your analysis and trying to tell your story. So for the women, it doesn't really work out so well. Because there were no agrees and everyone was strongly disagree. But on the male side, you can see this a little bit better. There still was only 1 agreement because there was no strong agrees. But as far as the disagree, we had 4 disagree and 5 strongly disagree. So that gave us a 9 total. And so it just kind of helps us see the percentages a little bit more clear than here, because we have all these variations, which might be important to your analysis if you are trying to look at gradations of a people's opinion. But here we can see that 82% of men disagreed with the statement versus 9% which did agree with the statement, and the statement was the proper way to prepare steak. And we just did the same thing, carried the totals across. I could even make this chart even more simple by getting rid of the whole row for neutral, because I'm really looking at people who have opinion for or against it. So I wanted to show you this. And I think when you're trying to compare the different tables, then, the data, making it simple, just agree and disagree, could be very helpful. So there's the simplified chart that we just built around preparing steak to maximize flavors to cook it rare. That was from our first. Again, just making a smaller, simpler chart so we can look at agreement and disagreement. And if we looked at the other statement that we did a few minutes ago, here's the simpler chart there. It just makes it easier to kind of compare if we combine all the agrees and all the disagrees, so we can look at kind of percentages on each side of the coin, if you will. When you're doing your PowerPoint, you're probably also going to want to create some charts. Pie charts tend to be very effective at communicating percentages. Here we see we have a very large percentage of agreement. And here we see we have a very small percentage of agreement. So it's confusing. Here we have a, so we have opposite things when we thought these should be alike. And so part of your discussion in your PowerPoint is, what are some possible reasons that the data doesn't disagree? Why aren't the females agreeing that it maximizes flavor as well as a top chef would cook it rare? And so you've got to be thinking through that, whether it's a process problem, I didn't interview enough people, whether it's some kind of other hypothesis about it, like, oh well, people may know that the proper way, or have heard things like the proper way to cook steak is rare. So they were answering not so much from a perspective of taste when they were talking about chefs as they were when we were talking about flavor. And so this can also give you some interesting insight, so that even though maybe we know that a good chef would cook it rare, I don't like it, and so I'm probably not going to eat it. And so then it goes to, well, wait, what would what was my original hypothesis, and how would that apply? Okay, these charts are really important. You definitely want to play around with the data, and you want to analyze all the data. I definitely recommend that you knock it down to just agree and disagree by combining the categories, and then kind of put them all together so you can look at them as a team and see what kind of conclusions that you draw. And that's really the biggest part of your project is doing that presentation and drawing all these conclusions. So the last thing I want to talk about is the idea about using other data. So in the example that we just walked through, the independent variable I used was gender. Let me pull up my pointer again, sorry. Was gender, okay? But I may notice something if I sort by age and the attitude statements that I'm interested in, that there may be some correlation, even though that's not part of my hypothesis. I would try to play around with some of this data, sort by age, and then sort, or count up the numbers, just to see if there's any other trends. And this can be part of your presentation too. This would certainly be going above and beyond. But a lot of your data, we have a very small group, or we may have a small group in class. And so looking at other data that's available to you is a very common thing when you're doing this kind of surveying and this kind of analysis. There may be something about relationships that's pertinent. Even though it may not be explicit in your hypothesis that you're testing, there may be some trends here that you want to look at. And you certainly don't want to just look at the one independent variable. Like in my case, I don't want to just look at gender. The next thing I would definitely look at is age. And certainly I would look also at spiritual affiliations and beliefs, thinking that might greatly impact it as well. So the bottom line here is that you need to build those charts, the actual numbers by independent variable and attitude statements and Likert scales, as we saw. Then simplify them, calculate percentages, simplify them, and then once you have those charts built out, that's when you want to sit together as a team and kind of talk through what are the implications. Does it prove your thesis, your hypothesis? Does it disprove your hypothesis? In either case, why? What's the rationale? What's your explanation for it? And what did you learn? What didn't? What do you need to do differently, etc. Okay. Hope this helps, and I'll be talking to you again.